Welcome to Samara Training Services. This is a talk in our Occupational Health and Safety series. This one is about using a bow tie analysis for the consideration of the risk of noise at work. My name is Jonathan Scope's. First, the bow tie. In a bow tie, at the top we have a hazard, a new hazard. And in this case it's going to be noise, but any hazard will result in a top event. The top event is something harmful happening either to the person or to some part of the company equipment. Things that can cause the top event are called threats. So these are the blue ones. Threats happen before the top event. Because of the threat happening, the top event happens and the harm is done. So we want to prevent those threats, and we can introduce barriers. Barriers are controls to stop the threat happening. And if they work well, they will control it and there'll be no top event. But it can happen that despite the barriers can fail, the top event happens. If the top event happens, we'll have a consequence. Consequences happen after the top event, and to stop the consequence getting worse and worse, we can introduce mitigations, which are like controls, but they stop the consequence becoming even worse. So let's look at this in the context of noise. So noise is our hazard, and hearing loss is our top event. Now, I've met people who have suffered occupational hearing loss, and it is harmful for them because they cannot hear normal conversation, they feel excluded socially, and they have many disadvantages as a result. They can't use phones, for example, for talking to people. So, we'd like to introduce some control measures. So the threats in blue are the volume or the sound pressure, because remember, noise is just a sound wave in your ear, so it's damaging the eardrum, so there's the volume. Another threat is how long you're exposed to this noise. Is it just for a short time, or is it all day, every day for months and months and months, a long time? Another threat is you're too close to the noise. We all know if we move away from the noisy thing, the noise reduces. So not enough distance. Another threat is lack of containment. We could put the noisy thing in a box, for example, but if there's no containment, it's a threat to our hearing. Lack of isolation. If the noisy machine is not isolated, separate from the structure, then the noise will carry further and closer to you. And then the last threat is we have no standard. We don't know if the noise is reasonably loud or unreasonably loud. So now we'll look at each of these threats in turn and introduce barriers. So for the top line, the volume, too much sound pressure in the ear, well, we could maintain the equipment. Well-maintained equipment runs smoother, runs quieter. We could buy quality equipment in the first place. Quality equipment will make less noise. It's better made. We can follow the manufacturer's instructions, perhaps for the maintenance or the operation of the machine, so it works as quietly as possible. And then we could, as a last resort, introduce ear defenders or ear plugs to protect our ears. So we could put barriers between the volume and our hearing loss, these barriers I've described. The next threat is the time. How long are we exposed to this noise? Well, the barriers might be have rest periods. So throughout the day there'll be a rest period where instead of working on the noisy work, you go and work on something that's quiet, giving your ears a break. You could introduce job rotation. So each person works, for example, 30 minutes on the noisy machinery, and then not again until the next day. And then you have many different people working for a short, approved period of time and no more. That's job rotation. and then we could limit the hours altogether. So we could limit the hours and say, with noisy work, we will not work more than 2 hours per day, as an example. Okay, so that's 2. The third threat is lack of distance. Well, if there's not enough distance, the first and obvious barrier is move away. We can either move the people away from the noise, or we can move the noise away from the people. We can put up warning signs. That would be another barrier. This is a noisy area, and people will know not to go there, or if they go there, to take the precautions. We can introduce zoning, and many process plants have zones. This area is high risk for noise, this area is medium risk for noise, and this area is acceptable noise levels. Or you could have access restrictions, and some plant is inside, some noisy equipment is inside a room that's locked. And only people who have the key and who have the training and the equipment for the noise protection can go in. These are barriers. Okay, the next threat is lack of containment. So containment means either putting the noisy equipment in a box, in an acoustic enclosure, in a room with solid walls and a solid door and seals, or we can put it in a box, or we can, alternatively, I suppose, but I've not shown it on the diagram, we could put the people in the quiet place and let the noise be outside. But we have some barriers. The next one is lack of isolation or insulation. So what could we do? Well, we can put the noisy machine, let's say, on springs or rubber mountings, so that the vibration and the noise are not carried, because the springs or the mountings absorb that energy. Or we could insulate, we could wrap it with heavy cladding to deaden the sound, to make it quieter. And the last threat we're considering is lack of a permit, or a lack of a standard. Okay? Well, we have standards. In Oman, the main standard is MD 286, 2008, and that does specify noise levels. You might have a company policy which specifies noise levels, or standards that specify how loud may the noise be before we have to do something. And there'll be industry guidance as well. If we put all those together, we now have the left-hand side of our bow tie diagram done. Now we'll look at, if those barriers fail and the top event happens, the hearing loss is happening, what can we do? What are the consequences? Well, the first consequence is what I'm calling acute hearing loss. Acute means short term. It means that you've had some hearing loss because of the noise, but if you stop now, your hearing will recover. So we could, as barriers, as mitigations, we could have measurement. So the person's been exposed to the noise, but now we measure it, and we read, oh, it's too loud, we need to do something. Or we can measure the person's hearing, and the hearing was at a high level, and now it's dropped a bit. We can't restore that, but we can stop it getting worse by taking some action. Or we can just remove the person from the noisy work. So that would be for short-term hearing loss. And chronic hearing loss means long-term. It's not repairable. Once the ears are damaged, that's it. The surgeons can't fix it. You've lost your hearing. Well, you could provide compensation. Here's some money because you've lost your hearing. But I think everyone would choose to have their hearing, not the compensation they'd get. Or we can change the work process. Someone's lost their hearing, and now we're going to learn a lesson and make sure nobody else loses their hearing in the future. So if we put those things onto the diagram, this is the consequence side of the bow tie. So we have, for acute hearing loss, we have 3 barriers. We have remove the person from the noisy work, measure the hearing, measure the noise. And for chronic hearing loss, we have change the work process or compensation. Now we put the whole thing together. Here's our bow tie diagram. And it shows all the controls that we have on one page, in one diagram. So we have 6 threats, managed with 19 barriers. We have 2 consequences reduced by 5 mitigations. You can follow us on Instagram, Twitter, LinkedIn, and Facebook. Thank you.